Hello people, Patrick here again. Today I'm going to talk about achieving a repeatable performance when you're dealing with particles in Maya. Let's create an emitter and let's make it directional instead of omni. 5. Make the particles spheres. Let's play it for a while. Gonna change that color to just blue. Okay, so now we're set to go. So let's give it a spread 0.3. Okay, so we can see that Maya gives us certain amount of randomization, and the way it distributes randomly, seemingly so. So let's sort of step through that simulation and see how it's randomizing the particles. So it's going up, the second one is going down, and the third one is going up, and the fourth one is sort of going a little bit up, giving us like a Y pattern. So up, down, up, and a little bit. So if I rewind this and sort of step through this again, we'll see that up, down, up, and slightly up, and then two straight ones, just like what we have. So if we rewind and play again, you know, every time we have this. So the seemingly random results from the attributes that we put in with our values is actually pretty accurate and stable, in that it can be repeated and recreated every time. Okay, what happens if I don't like this kind of distribution? Some of us would obviously like change it to like 4.99. Would it give us a, definitely it'll give us a different kind of, so up, down, up, not really, right? So let's change it to 4.85 maybe. Okay, it's sort of it's still retaining that random kind of pattern. The other way that actually works, that I would do, is using this in my particle shape node. We would, if it's emitted by an emitter, you would see that there's emission attributes. So some particles have more than one emitters, right? But this particle is just connected to emitter 1. So this random stream seeds will actually controls the randomization of the attributes that controls emitter 1 and how the particles are supposed to react. So if I change it to any other number, okay, so Maya allows for 1 to 100. Okay, so let's select 2, for example, or 0. So let's rewind that, step through. So it's a very different pattern than the Y that we had. So if I don't like that, I can go to 2 and I play it. It's a different, right? So we can see that it's different now. So that's the good thing. We're not just limited to one set of results for one kind of setting in the emitter. Okay, so that takes care of randomizing the consistent repeatability of Maya. So the second thing that I'm going to talk about is something that would happen if we make use of expressions. Okay, so what I'm going to do is randomize my colors. What I'm going to do is to use an expression to drive the RGB TP. So I'm gonna invert this connection and create an expression and give it a random color. Alright, so I'll just create a color randomizing 0 and 1, random 0 and 1, random 0 and 1. So having this, I'll just rewind and step through. Maya has randomized the color for me on creation of each particle. So I want you to remember this color. So it's magenta, turquoise, kind of off-white, and sort of bluish purple. Okay, I'm gonna rewind this and step through it again. You can see that now the color sequence is different. Okay, every time I play this. Okay, so what if there's something that I like, but I can't repeat it again? Every time I know that I'm going to rewind this and another stream of colors are going to come out. So what we can do is there's this mel command called seed, and we take just like the emission random number stream. Okay, once we use this, it will always churn out a predictable, repeatable result for us. So when we rewind and we play, we would see the same color for every particle. Why is that so? Because regardless of which particle that's churned out, this particle expression gets run every time, and every particle is, although it's random, but it's referring to using number 1 as their seeding value. So if I want to change this to another repeatable value, let's change it to 12, edit, and play it again. Again, every particle is referring using basing their randomization algorithm on the number 12. So it is repeatable, but that's not what we want, right? Of course, we can also base our randomization on frames. So let's play this. Okay, so every frame there's one particle being generated. So it's okay, so it's green, purple, green, green, pink, green. So let's play that again. Green, purple, green, green, pink, green. So it is repeatable, and it works for this simulation. However, if I go back to my emitter and I'm emitting more than one particle per frame, we would run into the behavior where, okay, let's put it to 20. We run into a behavior where every frame would generate the same color for any number of particles, because as you can guess, the seed we're using the frame number. So let's play that. It's a bit hard to see, isn't it? Yeah, it's a bit hard to see. Let me reduce the particle size. 0.4. Okay, and up the number of particles. 40. Okay, and let's step through this. So we're doing this seeding the so-called random values according to frame. So okay, you can see that on frame 3, 2 particles were generated and they were the same color. So let me step through. Okay, so red is generated on frame 4. That's just 1. And then 2 more particles were generated on frame 5, and they were the same color exactly. So okay, 2 more for frame 6, and they're both exactly the same color again. That's 1 on frame 7. 2 more green ones, so on and so forth. So we need to find another value that changes every time the particle, a new particle is generated, if we want every other particle to be different. Okay, so now we're basing it on frame. So if at frame 9 50 particles come out, 50 particles are going to be the same same color value because of the randomness taken from the frame number. So the solution to this would be using particle ID. Okay, so each particle would have a different particle ID, and we would be able to get a different color each time because the ID of the particle is different for everyone. So I'm going to change the emission rate back to 5, where we get particles coming out one at a time. Okay, so it's yellow, brown, purple, another purple, and red. So okay, and rewind that, play it again, and it's always constant and stable. So if I don't like this sequence of colors that I need, that I want to, I can always do a +1. Okay, if I do +1, of course we would know that that color is going to be sort of pushed down. What would it be? So particle 0 would get particle 1's color, and then particle 1 would get particle 2's color. So that would be what's going to happen. So we should see brown, sort of grayish purple, and then purple, then red. So I forgot to update. Yeah, so that same sequence was repeated without that brighter yellow in front. So there is some kind of control that we have. Actually, I'm just wondering if we could use float numbers. Yeah, it looks like it's the same. So if you want a wildly different color, different kind of color distribution, you would do a like +25 or something, or minus a fixed set of numbers. Okay, so once I have this seed in my expression, it affects all my other randomizing attributes. So for example, if I want to do a radius pp, just let me break that. Okay, and then I want to do radius pp equal to randomize between 0.4, 0.0, 6, and 1.2, 0.12, edit. So I will get, okay, so like 3 big ones, 2 moderate ones, and 1 more big one. So 3 big ones, 2 moderate ones, and 1 big one, and it's okay, and it's sort of repeating and in a consistent manner. Okay, so I hope it's been helpful to you, and that your simulations will be, from now on, be more controllable, and you know exactly what you're doing. You can get back the exact results thereafter. Thanks for watching. See you next time.